2, right? You don't need these two? 3 or 4? Anybody? Okay. Yeah, you need to be looking. I'll do these problems before we move on. Can we do number 4? Yes. Okay. What do you have to do? What's the rule? Get it to equal 0? Yes. So how do you move this? So I get m squared minus 49 equals 0. What do you notice about m squared and 49? They're perfect squares, right? Square roots, but that's okay. So what times what will give me m squared? And what times what will give me 49? Positive and negative. So when you set each of those equal to 0, you'll get, why do you just have a positive 7? Okay, do you understand how to do it now? Okay. That is a bad plan, probably. Well, that's not what you did. Right. You need 5 or 6? Yes, I can do 6. All right. What do you notice? 3x squared minus 12. Yeah, you got to take a 3 out. So I get x squared minus 4 equals 0. What do you notice about x squared and 4, though? Those are perfect squares. Yep. So I get x and x, 2 and 2. One's positive, one's negative. This step? This isn't true, but you still need to understand it, right? And you get x plus 2 equals 0, x minus 2 equals 0. You just stop there. Okay, you understand it now? Can I do number 5? Yep. I'm going to move everything to the left. So I'm going to add 3r and subtract 18. So I get r squared plus 3r minus 18 equals 0. The last sign is negative, which means my signs, one's positive, one's negative, right? R plus 6, r minus 3, right? 6 times 3 is 18. So then I get r plus 6 equals 0, r minus 3 equals 0. So it's negative 6 and positive 3. You see what you did wrong? Okay. Are you good? Okay. 7 or 8? 7? Right. Again, you're going to want to move them. You want to put it in standard form, though, which means the n goes in the middle. So n squared minus 6n plus 9 equals 0. If the last sign's positive, what does that mean when it's a plus? They're both negative or both positive. So you look here, these are both going to be negative. So I'm going to get n minus 3, right? What's going to happen, though, when you set each of these equal to 0? They're both just going to be 3, right? So what does that tell you about the x-axis? You just said it. It only crosses it once, right? Awesome. Awesome. That would be great. Thank you. Are you good with this one? Will you jump to number 9 then, please? Thanks. One more time. All right. Do I need to do this one? No? Okay. 11 or 12? Okay. 13 or 14? Go. 15? Okay. I was like, okay, why are we still going? No one's asking for anything. All right, I'm going to move this by subtracting. I'm going to add. So I get 7x squared minus 77x plus 168 equals 0. Is there a GCF? What? 7. So I get x squared minus 11x plus, I don't know. What? 49. Thank you. All right. So I want two numbers that will multiply to give me 49 but add to give me negative 11. Is 24. Oh. Okay. So I want two numbers that multiply to give me 24 but add to give me negative 11. 3 and 8. Thank you. So I get x minus 3, x minus 8 equals 0. So 7 does not equal 0, but you don't forget about it. So I get positive 3 and 8 as my roots. Okay, number 16. Yeah. Did you write this one down? Did you not do a GCF? Is that what happened? You tried to fact. Oh, so you slid it and then tried dividing it. It got really messy, didn't it? Because it was really big numbers. Don't forget about GCF, okay? All right, let's do this one. Minus 15n, so I get n squared plus 56. Oh, just kidding. I didn't erase enough. All right, now minus 15n plus 56 equals 0. So I'm going to get n minus something and n minus something. Good, 8 and 7. Do you see what you did wrong? Okay, so my roots are 7 and 8. I like to write them smallest to biggest, right? Your answer's still correct if you don't, but it just looks neater, I think. What'd you do wrong? What'd you do wrong? Oh, okay. Like the signs? Oh, okay. So 17, we're good? 18? Do 18. All right, I'm going to subtract 12. So I get 6r squared plus 6r minus 12 equals 0. What do you notice about each of those? What goes into 6, 6, and 12? I'm waiting for you to tell me. 6, thanks. All right, I was like, surely he's going to answer me, and then you weren't. All right, so r squared plus r minus 2 equals 0. So now I want something that multiplies to give me negative 2, but adds to give me positive r, which would be what? Right? So then you're going to set them equal, and you get negative 2 and positive 1. What did you do wrong? Did you factor out the GCF? You tried the slide and divide thing. It messes you up because then you have a GCF that you have to pull out at the end, which is confusing. GCF. Have to say that to yourself. Always look for a GCF, okay? What? If there's a number in front of the squared term, most of the time it has a GCF. Yeah, not every time, but a lot of the times. All right, this one? You're good? You need number 20? Okay. I'm going to add 3 in. So I get 3n squared plus 3n equals 0. What do you notice about 3n squared and 3n? Yeah, take out a 3 and a n. Yeah. So you get 3n when you bring that out. And what's left? N plus. No. What times 3n will give me 3n? 1. That's where you messed up. So I get 3n equals 0, n plus 1 equals 0. So n is 0 and negative 1, because you divided by 3, right? That's where you messed up. So we see all of our mistakes. Life is good. Are you good with solving quadratics by graphing and factoring? Are you? We're moving on today. All right, completing the square. I just looked and saw the smiley face. I was like, why is that there? I remember now. Okay, so when you complete the square, it's only with quadratics, okay? So remember that a quadratic is of this form, okay? Do you remember before we started talking about factoring? I said a quadratic has the greatest degree of what? What's the biggest degree? It's the biggest degree. Look at it. Look, 2, 1, nothing. So the biggest degree is square, right? Okay. So what's different about today, before we start completing the square, I'm just going to get you used to squares again, okay? So look right here. X squared plus 10x plus something. I want to be able to factor that into a perfect square, okay? So this is example 1. I guess I should write that. Example 1. I want to be able to factor this into a perfect square, okay? And the way that I can do that is you have to half this one and then square it, okay? So I'm going to half that number, then square. Then square it, okay? So what's half of 10? Okay, so half of 10 is 5. So now what am I going to do with that? I'm going to square it. So 5 squared is 25. So that's what you put right here. Wow, that's what? That's it. Now that you've done that, you could break this down into a perfect square, couldn't you? What times what would give me 25, but add to give me 10? 5. So x plus 5, right? But that's just like saying what? X plus 5 squared. Okay? Simple enough? Okay, you want to try one without me? Okay. I like to leave the blank because that makes you realize, hey, I got to half it then square it. So go ahead and try it. All right. You should be done. All of you should. You look done. What's the number that you get? Yeah, you put 144 here, right? So when I break that down, what goes in my parentheses? Yep, x plus 12. So that's actually x plus 12 squared. Pretty simple when it's an even number, right? You can half an even number really easily, can't you, and then square it. So the next example, we're going to talk about what happens when it's not an even number. You don't use decimals, okay? And when you're completing the square, leave it as a fraction, okay? And I'll show you why once we start completing the square, okay? Don't, okay? All right, so what's my number going to be? 5 over 2. When you square something, you're multiplying it by itself, right? When you have a fraction, you go straight across the top. So that's going to be 5 times 5, right? What is 5 times 5? 25. What's 2 times 2? 4. What do you notice about both those numbers? They're perfect squares. Do you see why I said don't put it as a decimal? Because when we actually start completing the square, you're going to want those numbers, okay? So this means that's what I put here, right? 25 over 4. So when I break it down, what's it going to be? It's my original number, right? It's this number. That's the number that always goes there, right? So it's x plus 5 over 2. X plus 5 over 2, right? So do you understand how to find it, how to take it and make it into a perfect square? Do you understand how to do it? You do? You can take any of them and turn it into a perfect square trinomial. Right. Any number that's odd, you just put it over 2. Any number that's even, it works out perfectly, right? That's not that bad, is it? All right. So now I'm actually going to start talking about completing the square, okay? Yeah, that's not completing the square. That's just making a trinomial into a perfect square. Okay? The example I want to do, x squared minus 13x plus 36 equals 0. Okay. Could you factor this? I could, couldn't I? Okay. If I factored it, what would my factors be? I want two numbers that will multiply to give me 36, but add to give me 13. 9 and 4. Good girl. Okay. So when you set those equal to 0, this just becomes what? 9, and this becomes a positive 4. So my roots are 4 and 9. Right? Okay. I'm going to do this problem by completing the square now. It was easier to factor it, wasn't it? But sometimes you can't factor it, so you need to know how to complete the square, okay? Are you good? I'm going to erase this, that way I can show you. All right, the first thing you have to do is you have to get the x squared and the 13x on a side by itself, okay? So what you do is you just say x squared minus 13x plus something. Remember when I had that plus in the blank? Do you remember that? We just did problems like that, didn't we? Okay, what I'm trying to do is make that a perfect square trinomial, okay? So I got to move that 36. What's it going to become if I move it to the other side? Negative. Now, can you add something to one side and not add it to the other? No, so guess what you got to do? You got to put your blank on this side also, okay? Are you good so far? Yeah. Okay. Now what do I have to do? I have to take that 13, half it, and square it, right? So I get 13 over 2. So this is what's going to go in my parentheses, isn't it, when I break it down? But I want to square it. What's 13 times 13? 169. What's 2 times 2? 4. So that's what goes in my blank. Now, most of y'all are not going to change that part to a fraction, are you? That negative 36? Are you going to change it to a fraction? No. Yeah, plus 169 over 4. So what you need to do is when you put that in your calculator and you get your answer, don't forget to hit math, then enter, because it's going to be over the fraction key, right? Frac, and then hit enter again. And that's going to give you an answer as a fraction, okay? So go ahead and do it. Right now, all you're doing is cleaning up that right-hand side, okay? Okay. Now, before I work with that right-hand side, this is what I was doing on the previous 3 examples, wasn't it? So all I got to do on this side is just say x squared, not x squared, excuse me. What's that become? No, not that side. That's not what I'm doing yet. Remember, it becomes minus 13 over 2 squared, doesn't it? Isn't that what we were doing on the last examples? Yeah. Okay. And on this side, if you did math, frac, enter, what did you get? 25 over 4. We're almost done, okay? Now, this is where the completing the square part comes in. Did I make this side a perfect square trinomial? Yes. That's why I can write it all as something squared, right? How do you get rid of a square root symbol? No, that would be just going backwards, wouldn't it? If you distribute the square. She said just distribute the square, but wouldn't that be going back to my original up here? And that's just going in circles, isn't it? How do you get rid of a square? Think about it. You just learned how to do it in the last unit. That's all we did in the second unit. How do I get rid of a square? Thank you. Square root it. But if you do it to one side, you have to do it to the other side. Okay? Now, when you square root a square, it just falls out, doesn't it? So you just get x minus 13 over 2. Don't forget when you square root something or it's an even, what does your answer have to have with it? Who remembers? Come on. When you have an even index, right? That's a square. It's not written, but it's a square root, isn't it? When your answer is an even index, what has to go with your answer? Do you remember? Sidebar, here we go. I need you to be thinking today. What's my choices for this? What times what will give me 4? 2. But what else times itself will give me 4? Just positive 2? Oh, positive or negative. Do you remember that? Yeah. Don't forget that, because guess what? This is actually positive or negative. What's the square root of 25? 5. What's the square root of 4? 2. Do you understand why you learn radicals first? Yeah. Okay. How do you move this 13 over 2? You add it, right? So I'm going to get x equals 13 over 2 plus or minus 5 over 2. If it's a plus or a minus, you're going to have 2 answers. Good job. I'm going to erase this down here. Y'all okay with that? So look, this breaks down into 13 over 2 plus 5 over 2 and 13 over 2 minus 5 over 2. Okay? What's 13 plus 5? 18. What's 18 divided by 2? 9. What's 13 minus 5? 8. What's 8 over 2? 4. Did you just find your roots? 4 and 9. It's a longer way, right? If you can factor it. But if you can't factor it, you can complete the square, okay? Factoring does not always work. Completing the square will. They're the same denominator. No, they'll be the same. If it's an even number in the middle, then that 2 falls out, right? Which is really nice. But if it's an odd number, it doesn't. How did it get it? Because I have to get x by itself, so I have to add 13 over 2. And if you put it in front of the plus or minus 5 over 2, that'll help you remember that, hey, it's 13 over 2 plus 5 over 2 and 13 over 2 minus 5 over 2. Where? Right here? You have to square root this whole side to get rid of that square. But if you square root one side, you have to square root this side. That's why. And then the square root of this right here, remember, you can break it down, can't you? So it's actually the square root of 25 over the square root of 4, right? The square root of 25 is 5, and the square root of 4 is 2. That's why you learn radicals first, because if you didn't, this wouldn't make any sense, even though it apparently doesn't make any sense anyways. It's okay. It's a lot of steps, but once you do it a few times, you'll be okay. I'm sure. All right, you ready to try the next one? Do you want to try it without me? Why don't you just take a few minutes to see if you can at least set it up, and then I'll help. Did all of you try it? No, not by factoring the long way. The whole point is to learn how to complete the square. These I'm giving to you so that you know what you're trying to get to, right? Because you can factor it, correct? What happens when you can't factor it, though? You got to do it this way. So why not just learn to do it this way, right? The first thing, if I move this to this side, what does it become? Positive. So I get 6. And then if I add something to this side, I have to add it to that side, don't I? Yeah. You moved it to the other side. It has to become positive. Listen, if there's no number here in front of the x, what's that like saying? It's a what? It's a 1, right? We don't write that in math class, do we? So now I'm going to go over here on my side. This, when I half it, just becomes what? 1 over 2, right? And then you square it. What's 1 times 1? 1. What's 2 times 2? 4. Look, they're both perfect squares, okay? What number goes in parentheses, though? That number, right? Don't forget that. So I'm going to add 1/4 to this side, but I have to add it to that side also, okay? So when I break it down now, I get x plus 1/2 squared. Isn't that what I wanted? Yes, that's what I wanted. Okay, what is 6 plus 1/4? Math, frac, enter. What? 25 over 4. What do you notice about 25 and 4? They're perfect squares. So how do I get rid of a square? Oops, excuse me. Yes, you square root it. But if I do it to one side, I have to do it to both sides, right? So now I have x plus 1/2 equals, what's the square root of 25? 5. What's the square root of 4? 2, but it's plus or minus, right? Because it's an even index. Remember that, okay? That's what messed you up then. Whatever it is that you square is what goes actually in the parentheses, okay? But you have to square it in order to know what to add to both sides, okay? That's why I put the arrow for myself right here. Because that's like, hey, don't forget, I'm the one that goes in parentheses, okay? But you square it to see what goes on both sides, all right? All right. How am I going to move that plus 1/2? Subtract it. So I get x equals negative 1 over 2 plus or minus 5 over 2. Come in. Here we go. Let's finish this problem. I'm going to break that down into 2 cases, right? Negative 1/2 plus 5 over 2. Negative 1/2 minus 5 over 2. Okay? What is negative 1 plus 5? Negative 1 plus 5. 4. But 4 over 2 is 2. Negative 1 minus 5. Negative 6. But negative 6 over 2? Negative 3. So my roots to this problem were actually negative 3 and 2. Did you find those by factoring? Why is the 1 negative? Because it was positive here. So when you add it to the other side, you have to subtract it to get rid of it. Are you good with that one? Listen, I want you to complete the square, not factor. That would be pointless, wouldn't it? It would be day 3 of factoring. Why would I do that? We don't have time. Well, I'm not nice. I want you to learn. All right, example 6. Let's talk. Do you know anything that will multiply to give you 13 but will add to give you 4? No. So could you factor this problem? No. Do you understand? Do you understand why you need to learn how to complete the square? Yes. I'm not laughing, y'all. Really. I need you to learn how to do this. You're always going to add it because when you square it, it's a negative, right? Listen, when you half it, the sign stays the same, right? So look right here. It's a minus. So when you break it down in parentheses, it's going to be a minus. If it were a plus, when you broke it down in parentheses, it would be. But still, it always becomes addition because think about it. If you square the half of 4, what's half of negative 4? Negative 2. But when you square that, it becomes 4. So do you see why you always put plus blank, plus blank? Because you're always adding to both sides, okay? Do you get it now? Okay. All right. I already told you what's going to go in parentheses, right? You just had to fill it in. Listen, you move this to this side, right? So it's going to be x squared minus 4x plus a blank. Why did I say it's always plus the blank? Because even if you square negative, it's always a positive. Okay. Equals negative 13 actually becomes 13 plus the blank. Now, what's half of negative 4? Negative 2. Isn't that what I put right here for you? Yes. Why am I putting the arrow for myself? Because that's what goes in parentheses. Once you square it, what goes in the blanks? 4. Thank you. Okay. Are we good so far? All right. So now, x minus 2 squared equals 13 plus 4? 17. Don't freak out. It's okay. You put it in the square root house. So, I'm going to square root it. Yep. So, when you square root a square, it becomes x minus 2, right? Can you square root 17? Can you simplify the square root of 17? No, you can't, can you? So, it's just plus or minus the square root of 17, right? Okay. How do I get rid of that 2? Add 2. So I get x equals positive 2 because I added it, plus or minus the square root of 17. Guess what? That's a number, isn't it? Right? So you leave it like that. I don't want a decimal that goes on forever. So if you wrote your roots out, it would be negative, no. Excuse me. It would be 2 minus root 17, 2 plus root 17. There's your 2 roots. If you put 2 plus or minus the square root of 17 all in the bracket, I understand. But if you don't understand that that's 2 different numbers, I want you to split it up. No. Because it was a new SOL last semester, we had to wait until enough students in the state of Virginia took it to validate it. You don't need to understand that stuff. So anyways, it took 3 months to get the scores back. But since they've already validated it, this semester it'll be like any other time. It's pretty much immediate. You get the scores back. You know, if you take it in the morning, we'll have it by that afternoon or the next day. Next year, it's a new SOL for science. So kids that take science first semester will not get their scores until February of the second semester. No, you're good. If you would have had me last semester, yeah, we would still have found out. But yeah, if you can't square root it, you leave it. If you can simplify it, you should always pull that number out, okay? Because we learned that forever ago, didn't we? All right, here we go. What example is this? 7. Thank you, 7. X squared plus 6x plus 8 equals 0. Possibly, but when you move it over, it doesn't matter. You always have to move it away. Here we go. What do you have to do first? Move the 8, right? So what's going to happen when you move it to that side? It's going to become negative. And I always can put plus a blank, right? Always. So negative 8 plus a blank. What's half of 6? I'm going to write it over here because I'm tired of walking over there. So 3, and then I have to square it, right? So that's what goes in my parentheses. 3 squared is 9. So that's what I have to put here, right? Which gives me x plus 3 squared. Isn't that what I'm trying to do? Yes. What's negative 8 plus 9? 1.
Oh, I get what you're doing now.
I'm not square rooting it yet. Here we go. Now we square root. Right? So I get x plus 3 equals plus or minus. What's the square root of 1? 1. I move the 8 to the other side by subtracting 8. Do you understand now?
So that's your answer right there?
No, that's not my answer. How do I move this 3? Subtract it. So I get negative 3 plus or minus 1. That means how many answers do I have? 2, which is negative 3 plus 1, negative 3 minus 1. What's negative 3 plus 1? Negative 2. What's negative 3 minus 1? Negative 4. Which one's smaller? Negative 4. Very good. Negative 4, negative 2. Look at the original problem. Could you have factored it? Yeah. Do I want you to?
Yes.
No. No. Sometimes after we get done with everything, quadratic-wise, okay? But at the moment, with today's homework and tomorrow's homework, you're forbidden. Do you hear me? The only way to learn how to do this is to actually do it, okay? You want another example? But I'm going to give you one. That's right. Here we go. Example 8. All of you should be able to do this one. X squared plus 4x minus 12 equals 0. Here we go. X squared plus 4x plus, leave a blank, equals, how do you move that negative 12? Add it. So you get 12 plus, leave a blank. Okay. Half of 4 is 2. So that's what goes in my parentheses. 2 squared, though, is 4. So that's what goes in my blank. Right? So I get x plus 2 squared equals 12 plus 4, 16. Okay? Now what? Square root it, the house. Yep. So I get x plus 2 equals square root of 16 plus or minus 4. Please don't forget that, okay? All right, how do I move this positive 2? Subtract it, so I get negative 2 plus or minus 4. So I get negative 2 plus 4, which is 2. Negative 2 minus 4, which is negative 6. So my roots are negative 6 and 2. Are you doing it right? Here's a different type of problem. I'm doing this for a reason. What example is this? 9? I want you to see if you can tell me why this is a different type of problem. Who sees why it's different? Why? It's negative. Do you see why you learn complex numbers first? All right, so when you move this over, it becomes negative 22, right? So I get x squared plus 8x plus blank equals negative 22 plus blank. So what's half of 8? 4, but I have to square it. 16. Negative 16 plus, or negative 22 plus 16. Negative 6. What happens when you get to this step? You have to square root it, right? But what happens when you have a square root, a negative under a square root? What do you bring out of the house? The negative, which we learned was what when we learned complex numbers? I. Do you remember that? So this is actually x plus 4 equals I plus or minus the square root of 6. Or actually, it would be plus or minus I. Yeah, there we go. I root 6. Sorry. So how do I move that? You can't take the 6 out. Think about it. Yeah. Can't reduce that, can you? So my answer would be x equals negative 4 plus or minus I root 6. Then you take it out, right? Well, think about it. Remember I said there isn't a real solution, but you have solutions still. These are the solutions. They're just imaginary.
Oh, so like the ones we can't solve.
The ones you can't solve, you can complete the square.
So pretty much we're doing what you said,
Where you can find the answers even though you can't see it visually on the graph. That's what we're doing. Yeah. All right. Let me show you one more thing real fast. I'm not going to solve it. We're just going to talk about it. Here's your homework problem, so write them down. It's only a few. Number 1, x squared minus 2x plus 1 equals 4. Would you do it the same way? Listen, it's the same, except that's not a 0, right? So when you move that 1, you literally just do 4 minus 1, right? Which is 3. Then it's the exact same kind of problem, okay? There's a reason why I put that one first. Because I wanted to talk about it. I'm not showing you how to do it. No. It's 4 problems. You can try them. Yeah. That's it for homework. Because this is difficult, right? It takes a little while. How are you supposed to do these 4? No. By completing the square. Do not do these problems by factoring, and I'm not kidding. Don't tempt me to give you more than 4 problems for homework. Listen, the first one is the exact same thing, right? Except you got to subtract the 1, and since it's not a 0, you have to combine them, okay? Good with the homework problems?